Today we're going to talk about project scheduling, and we're going to focus on a few project scheduling tools such as those ones listed here, the CPM, PERT, and project crashing. When we talk about project scheduling, we're trying to convert the project action plan into an operating timetable so that everyone on that project team will know when each event will happen and when to carry their assigned tasks. Project schedule is a major tool for managing projects. If you recall, when we manage a project, there are 3 different dimensions that we manage, and project scheduling dealing with that time dimension that we need to achieve. And there are different ways to portray the project schedule. One method is the network technique, where we form a network of activity and event relationships, where the sequential relations between the tasks in a project are portrayed, and the tasks that must precede or follow other tasks are also clearly identified in time and function, so that people understand the relationships among those different tasks, that which one need to happen first until the others can happen, and when should certain activities happen. And we can also use a progress chart or Gantt chart to show the planned and actual progress for project task on a horizontal time scale. So if we talk about the network technique, we mainly refer to the CPM and the PERT. CPM is called the critical path method, which was developed by DuPont Company in 1950s. And this method was originally designed for construction projects, but later applied widely in project management, regardless of the field. And the PERT is called the Program Evaluation and Review Technique. It was developed by the U.S. Navy for missile submarine projects, also in the 1950s. And now it is primarily used for R&D projects because of the nature of those projects being with more variability and uncertainties. The 2 methods are quite similar, and in fact, the PERT method built on the CPM, and they are also combined in the project management discussions. They both identify a critical path and also indicate activities with the slags, which means activities that you can delay. And their main difference is that the PERT method uses probability activity time estimates to help determine the probability of projects completed by a given date. So it's different from the CPM, which does not give you probability for the activity or the project being completed by a given date. It basically gives you when that project can be finished and tells you the early finish time and late finish time of those activities within this project. The PERT method will basically give you an estimate or the probability that if you want this project be done by a certain date, what's the probability that you would achieve that goal. And for CPM and the PERT, the terminologies are used the same. And when we mention an activity, it means it's a specific task that required to be done if the project is to be carried. And that specific task will use up resources and also will take time to complete. For example, when you create a design, you will do the research. The research would be one activity. And if you further divide that research into different categories, the task that you need to complete in each category will be an activity. So depending on how big and how complex your project is and how detailed your work breakdown structure is, that activity can be at different levels, but they all require resources and take time to complete. An event is the result of completing one or more activities. For example, if the research is done, then that's an event. So the research itself is an activity, but when that activity is done, is completed, then we call that an event. When research is done, so when that event happens, we can move on to the next stage of your design. And a path is a series of connected activities between any two events in a network. For example, you first identify the problem and then you justify the problem that you are going to solve. So identifying the problem is one task or one activity, and justifying the problem is another activity. When you connect those two activities together, it represents a path from identifying to justifying activities. And when identifying the problem is done, that's an event. And when we talk about critical, it can be used to describe activities, events, or paths. And when we say an activity is critical, or when an event is critical, or if a path is critical, we are saying that if that activity, that event, or that series of connected activities, or that path is delayed, then the project will be delayed. And critical path will be the sequence of critical activities and events that connects the project start event to its finish event. So all the activities on that critical path are the ones that cannot be delayed, otherwise the entire project will be delayed. And when we have a logical sequential arrangement of all the activities and events represented by arcs and nodes, we have a network. So when we have the activities connected or events connected, we have paths. And when we have those paths connected, many times we have parallel paths, sequential paths. When they are all connected, you will see a network. And before an event can be achieved, all activities that immediately precede it, or those activities that are its predecessors, must be completed on this network. There are two types of networks that the project management use. One is activity on arrow, and the other one is called activity on node. In the activity on arrow method, each activity is represented by an arc. So you would draw an arc to represent an activity. And a node is used to separate an activity from its immediate predecessors. The sequencing of the arcs shows the predecessors' relationships between the activities. So when you have an arc that represents one activity, you would connect it with two nodes to separate it from the next activity. So this would be, say, activity A, and this will be activity B. And in the other one, the activity on node method, each activity is represented by a node. So instead of using the arc to represent it, this will be an activity. So the activity will be in this node, and we'll use the arc to connect them to represent the precedence relationship between these two activities. So in both networks, A is the predecessor of B, meaning that A has to be completed before you can move on to the B activity. Now, if we want to use this example to illustrate the network, we are going to look at how we draw the activity on arrow and the activity on node networks. So in this example, we have this action table here, and we have 3 tasks listed. A does not have any predecessors, and B's predecessor is A, C's predecessor is B. in this action table, we also have the time it needs to complete each task. So if we draw the activity on node example, we would have the activity, which is, say, the starting of the project as the first activity, and then it goes to the next one, A, which lasts 5 days. And then you can complete B, which lasts 2 days. Then you can move on to C, which lasts 3 days. Then you will have an activity. That means the project ends. If we use activity on arrow, then we'll have a starting node represent the project start. And then you would have the first activity, which is the A. So you see, you will write the task A and its duration 5 days on this arrow instead. And then once A is complete, you can move on to B, which is again denoted on this second arrow here. B lasts 2 days. And then you can move on to C, which lasts 4 days. And in this example here, the node 1 and node 4, remember we use nodes to represent events. So node 1 and node 4 will represent starting of the project and the completion of the project. And if we look at another example here, we have one more task, so A, B, C, D, and again, A is the starting task. We can tell that by looking at the predecessor column. A does not have any predecessors, so that means A is the very first task to complete when the project starts. And A is the predecessor of B, so B would be the activity that follows A. Then we look at here, B is the predecessor of both C and D. So that means once you complete B, you can start C and D at the same time. So C and D would be two parallel activities that follow B. Again, this action table denoted how much time does it take to complete each of our tasks. So if we create the network for this example here, an activity on node network would have, again, a start activity, start the project. Then the first activity will be A, which lasts 5 days. Once you complete it, you can move to B because A is B's predecessor. So you can move to B. B takes 2 days to complete. And once you complete B, you can move to complete C and D at the same time. So these two can start at the same time and go in parallel. C takes 3 days and D takes 4 days. Once both are done, then the project is done because C and D are the last 2 tasks to complete for this project. And if we look at activity on arrow, you'll see that A and B will be very similar to the previous example, but for B, we have 2 tasks or 2 activities that follows. So we can go from this node here. This 3 is an event, meaning the completion of activity B. And then once B is complete, we can start C and D. For C and D, we can use the same arrow, so we use 2 separate arrows. So one way to separate them is to go with this way. So we have D leading to another node and create a dummy arrow, represent an activity that does not need any time or resource to complete and still connect to this 5. So this event 5 here, this node here represents the completion of the entire project, which depends on the completion of both activity C and D. Now we're going to use activity on arrow for this example here because activity on node is relatively simple than activity on arrow. So we're going to focus on activity on arrow method in this class because if you master this one, it will be easy for you to do the activity on node networks. So let's look at this example. In this example, we only have the predecessor relationship for now. And that's the usually first step we start. We don't worry about the duration first. We figure out the relationships among all those tasks, all those activities, and draw the framework of them first. And then we start to fill in those details, such as the durations. So if we look at this one, by looking at the predecessor column, we see there are 3 activities that do not have predecessors. A, B, C. So what does that mean? That means A, B, C, these 3 activities will be the first 3 activities we can complete, or we should complete when we start this project. And they don't have any predecessors. The only predecessor, if we want to say, is the starting of the project. So once the project gets kicked off, we start to do A, B, C in parallel. Okay, so you would imagine that we will have 1, 2, 3 arrows. Now this represents the starting of the project. And then we would have A, B, C as the 3 activities that we finish first. And then we continue to look. So A is the predecessor of both D and E. So that means after A is complete, we can have D and E to start. And D and E will be, again, 2 parallel activities that we can perform at the same time. Then B is a predecessor of F. And we're going to have F following B. I'm going to add those arrows here. And the C is the predecessor of G. G is here. Now D is the predecessor of H. So after D, we can add H. Here, both E and F are the predecessor of I. So when we see this, we'll think about the E and F both need to be complete before we start activity I. So this E and F would end up going to the same event node, representing both E and F are done. We can go to I. And after that, we see there are no more tasks or no more activities to draw. So what does that mean? If we look at here, H, I, and G, these are the activities that have no more activities following them. So once they are done, we are done for the entire project. So we're going to connect them to the same node, representing that the project is done. So when you first create this network, I would suggest you use pencil. Or something, if you work electronically, that will be easy. You can wipe out those network, those arrow here, and you can easily change it. So you see, this is the framework of our project. If we put it in a nicer way, it will look like this. And in this slide, the duration of those activities are given. You can see here, A lasts for 8 days and B lasts for 20 days. We'll assume that we'll use days as the time unit. Okay, sometimes it could be weeks or months. So here we have those durations, and then we can study and figure out when this project will be done. Say if we start today, when will be all the 3 activities be done so that the entire project can be done. Now let's look at another example here. This was the original project, okay? And here, if we change the predecessor relationship for F, so instead of having B as its predecessor, now both B and C are the predecessors of F. How do we change the network to represent this? If we look at the previous one, F has a predecessor, which is B. Now, we figure out that, some requirement changed. In order to carry out F, C also need to be done. So how do we change it? Do we create another arrow to represent C here? So we have C as the predecessor of F and also C as the predecessor of G. Is this a right approach? The answer is no. We can use 2 arrows to represent the same activity. So let's erase this out. So C is here. How do we make it represent it's also a predecessor of F? We're going to introduce this dummy arrow here. So you can see that C now is also a predecessor of F. So F have to wait until both B and C are completed because of this dummy arrow here. So the use of dummy arrows can be very useful, especially in situations where you need to represent the predecessor relationship and it's hard to just connect those together. So in this case, we can just connect C here because we talk about that we can use 2 arrows to represent one single activity. Then some of you may be thinking, wow, what about we wipe out this one? We don't use this one. Now C goes here and then G goes from there. So we'll wipe this entire thing out. Then in this case, both B and C goes to this node here. This event representing both B and C are done, and then F can start. And also, because C is the predecessor of G, so G comes out from here. Is this correct? What do you think? Is there a problem if we draw the network like this? If we look at our relationship, G's predecessor is C. If we look at our network, by drawing B and C to end to this one node and have F and G coming out of this node, we are indicating that both B and C are the predecessor of G, which is not true. Only F has B and C both as its predecessors, not G. G only has C as a predecessor. So you can see that using that dummy node is the right way to do it. Okay. So the use of dummy activities sometimes is necessary in this activity on arrow network to properly indicate the precedence using a dashed arc. Dummy activities has no duration and uses no resources. So when you see in a network where you have those dotted arrows, they represent those dummy activities. And remember that they don't take any time or resources. Sometimes we only need just a dummy arc, like those examples we showed earlier. And some other times we may need to add a node too. In this following example, A precedes D, A and B precede E, B and C precede F, but A does not precede F. See if this is a correct representation of this relationship. So let's look at the first one. A precedes D. So A precedes D. That's correct, right? So D goes after A is complete. And the second one, so we can check this one. A precedes D. Then A and B both precede E. So E need to be started until both A and B are done. So because of this dummy arrow here, we do have what we want. So E cannot be done until A and B are done. So this is correct. Then here, B and C precede F. So F cannot be done until B is done here and the C is done. So B and C is done. However, if we look at this one, we are indicating that A is also a predecessor of F because of this path here. This path with these two dummy arrows. But in the problem statement said A does not precede F. So when we add these two dummy arrows here to achieve the purpose that E's predecessor are both A and B, and F's predecessor both B and C, we added another condition that A has to be done before we can conduct F, which is not true. So how do we solve this problem? How do we modify this network so that we can correctly represent this predecessor relationship?